All right, psychology. We are going to wrap up our unit on intelligence today. We are basically going to talk about a few principles of IQ testing and intelligence construction and things like that. So, the first thing we're going to jump into is this idea of standardization. Okay. And if that sounds familiar, it's probably because you guys are from the generation of standardized tests, right? So, you guys probably have an idea of what standardization is and what standardization means. But let's talk about it according to IQ scores. Okay. What we do with IQ scores and what we do with a lot of things in psychology and a lot of things in research in any kind of scientific field is we standardize them, which means we force them to fit into this bell curve, right? So when we're looking at intelligence, this is just one example of a standardization into a bell curve. Now you're going to hear this called a lot of different things: a bell curve, a standard normal curve. It goes by a lot of names, right? But basically, what it means is we are going to put your scores into this bell curve, and most people are going to score around the average. And as you get further away from the average on the high end or the low end, you're going to see fewer and fewer people score in those areas, right? So when we're talking about a normal standard curve for IQ testing, and if you look down at the very bottom, we're talking about the Wechsler IQ test, the most common IQ test that is given, right? We see that the mean score, which is the score right there in the middle, is 100, right? That goes back to our conversations from last lesson when we were talking about mental age over chronological age times 100, equaling 100. So 100 is the average score. Now look at those percentages down there. That 34% on the bottom and the 34%, bottom left and the 34% on the bottom right, that is your one standard deviation, okay? Now, what does one standard deviation mean? We've talked about standard deviation a little bit in psychology, but we've not really expanded on it. First thing I've always said is I'll never have you calculate standard deviation. It's not something you have to do for AP psychology, but you do have to understand what standard deviation is. And it is a standard deviation or change from the mean score. And with this IQ testing, if we go up one standard deviation, then we add 15 points to your test because the standard deviation for the Wechsler IQ test is 15. Okay, 15 points. So if you go up one standard deviation from that 100, you go to 115. And also, if you go down from that 100, one standard deviation, it's minus 15. So 85 to 115 would score within one standard deviation of the mean score. What does that mean? That means most people. Take a look at this percentage. This is what's super important. This is what you need to know. 68%. 68% will never change. That number will never change. We force the numbers of anything we put into this standard normal curve to fit that 68%. 68% of people will score or be within this measurement between one standard deviation below and one standard deviation above our mean score in this case, which is 100. So if I gave all of us an IQ test today, right, this curve basically would say that about 68% of us would score between an 85 and 115. That's a normal score on the IQ test. Now, let's go into an expanded version of those extreme high and extreme low scores. Let's go out another standard deviation. So we add another 15 onto the high side, we subtract another 15 onto the low side, and we get to the numbers 70 and 130. Now, when you get to this, two standard deviations below and above the mean score, now all of a sudden you're talking about 95% of the population. This is almost everybody, okay? So you're going to find that everybody that takes an IQ test is probably going to score between that 70 and 130. Now, what happens if they're outside that range? Well, these are very rare instances, right? People who score above a 130 on the IQ test, the Wechsler IQ test, that's our designation for giftedness. So those people are extremely intellectually gifted. So you're talking about, your Elon Musk, your Bill Gates, your Albert Einsteins on that high end, right? You go down below 70, that's actually our threshold for intellectual disability. We used to call that mental retardation. We don't use that word anymore. The R word, retardation, got some negative connotations about it, so we don't use it anymore in psychology. The DSM changed that to intellectual disability. But those are the people who are really going to struggle with intelligence testing. So 70 to 130, 95% of people are going to fit in there. So let me say a couple things about this, right? It doesn't matter what you put in here. Let's change it. Look down at the bottom. Let's change it. Let's not do IQ scores anymore. Let's do height. Height is something that actually develops into a normal standardized curve. So if we take away those scores, take a look down at the bottom, take them away, right? And we put an average height of 5'9" for an American adult male in the United States. And we ask ourselves, how many inches up and down are we going to have to go to fit 68% of people within one standard deviation of that height? you're probably going to come up with a number around 3 inches, right? Because if I plug in that number, 3 inches above, 3 inches below 5'9", I get to 5'6" to 6 foot. Now, are 68% of adult males in the United States going to be between 5'6" and 6 foot? 68%. Yeah, that's going to be pretty close, okay? Maybe it's somewhere between 3 and 4 inches, but that's going to be a darn close measurement right there. And then if we go up another 3 inches and down another 3 inches to our second deviation, we would go down to 5'5" and up to 6'3". And we ask ourselves that question again. If we're just kind of, playing with the numbers here and guessing, would 95% of males in the United States, adult males, be between 5'5" and 6'3"? And once again, I would say, yeah, pretty close. Now, you're going to have your extremes, right? You're going to have your people who are above 6'3", and if you were just looking at basketball players in the NBA, most of them would be above 2 standard deviations above the norm for height. But, that's an extreme case, right? So, yes, I would say that for height, standard deviation is probably going to be between 3 and 4 inches, and your average height is going to be around maybe 5'8" or 5'9". So it does develop into this normal standard curve as well. So, all right, so let's move on. One thing that we have seen with IQ scores is the Flynn effect, okay? Now, this Flynn effect is really hard to explain, but I'm going to try my best, right? And I also put a video in from James Flynn himself, who it is named after, kind of explaining the Flynn effect and his ideas on why it's happening. But here's the Flynn effect. Basically, when you look at IQ scores over time, and we're looking at this idea of standardization, IQ scores have went up over time. You probably could have guessed that. But what maybe you don't guess is they went up drastically. They've not just went up; they have skyrocketed with each generation. With IQ score testing. So when James Flynn attacks this question, he's basically asking why. Why is this happening? And he says when you're looking at it, it's basically like if you were to test your grandparents, right, and compared their IQ scores on the Wechsler with your guys' IQ scores, most of your grandparents would score in the range of intellectual disability, right? And if we were to take our scores and put them into the normal standard curve back then, we would all be gifted, right? We would all, probably score over 130. And he's like, why is this happening? Are previous generations that much more dumb? Are we that much more special and intelligent, right? And he says the answer is probably somewhere in between. Here's probably what's happening. He hypothesizes a couple things, but here's the one that makes maybe the most sense to me. We are now very good at considering the hypothetical, where maybe in the past they were not very good at considering the hypothetical, which basically means when we're given a hypothetical problem, we attack it like a real problem. Where in the past they would probably maybe try to use some empirical evidence and maybe their own experiences to answer that hypothetical question. And that's maybe not something that you can do if it's a hypothetical question that, doesn't have any bearing to you. He gives the example of, when they asked people in 1930s about, a bear in the Arctic Circle, right? And he gives them this logic problem. He says, all bears north of the Arctic Circle are white. And then he simply asked them, if you went to the North Pole, what colors would the bears be? And he was shocked to find that most people would not just say, oh, well, they would be white. They would want to know if anybody had been to the North Pole and seen these white bears. They basically weren't going to just accept it without some kind of eyewitness testimony or empirical evidence. So they just didn't consider the hypothetical as much as we do now. So that's just one example. But I'm gonna leave the video up for the Flynn effect and James Flynn talking about this theory. As a supplemental video. So if you want to check that out, you can. Okay, there's a little preview of it. Okay, I'm not going to show it to you, but you guys can watch it later if you want to. Next thing we want to tackle here, the difference between reliability and validity. Now, for you AP psychers, this could definitely be something that comes into the AP test because reliability and validity are two terms that are often mixed up and often mistaken. So let's go over this real quick. Reliability is basically the idea that a test yields consistent results. Okay. If I'm a teacher and I give out an A version of the test and a B version of the test, my main concern is those two tests better be reliable. which means the A version better be assessing intelligence at the same level, or assessing a Unit 11 knowledge, right, at the same level as which the B version does. One can't be harder than the other, one can't be easier than the other. They have to be reliable, they have to yield consistent results. So a few ways that you can do this is, you can give out tests that have maybe 50 questions on it, and score the first 25 and the last 25, and make sure that the difficulty is about the same. Make sure the test yields about the same results. Also, another way you could do it is have somebody take the entire test and then look at just the odd questions and the even questions to make sure that these questions are reliable. Okay, so basically you're looking at, do the scores correlate between one half of the test and the other, or if I have an A version and a B version, do those yield consistent results and have about the same, right? If I give an A and a B version, and the B version mean score is like 89 and the A version was like 72, my test is not reliable, okay? And it's a bad test, and I have to make sure that I go back and fix that, right? So that's reliability. Validity is something completely different, okay? So validity is the extent to which a test measures what it's supposed to measure, okay? So if I gave you a Unit 11 test and it had a bunch of questions from Unit 3 on it, that test is not valid, because I'm saying this is a Unit 11 test, assessing your knowledge over what you've learned from Unit 11. If it's a bunch of Unit 3 stuff and I'm asking questions about neurons in the brain, that doesn't let me know what you learned during Unit 11, so that test is not valid. Big questions about validity come up on aptitude tests, right? So if you remember our conversation from last class, we talked about the difference between achievement tests, measuring stuff you've already learned, versus aptitude tests, measuring your ability for future learning. So one thing's with the SAT or the ACT is, are they valid? Do they really predict what they say they predict? Do they really predict your ability for future learning? Right. So a lot of times the SAT will look at how people score on their test, their SAT test, and then what level of college education they attain, or do they go on to master's work, or do they go on to PhD work, and see if those scores correlate with that. So, when you're looking at achievement tests, a lot of times you're looking for content validity. Are you testing the content that you taught? If you're looking at an SAT test, a lot of aptitude tests, they're looking at predictive validity. Are they predicting what they say they are predicting? Okay. And then here's our last slide, crystallized and fluid intelligence, another two terms that are mixed up often, so make sure you know the difference here. Main difference here is crystallized intelligence does not decrease with age. Fluid intelligence does, okay? Crystallized intelligence is basically our accumulated knowledge of facts and verbal skills and things like that. Those don't go away with age, right? I mean, I talk about my grandpa a lot. My grandpa was, a construction guy, and he built like 3 or 4 houses from the ground up. So he knew everything about building codes. Did he forget all of that stuff as he got older? No. He accumulated all that knowledge because it's crystallized intelligence. He could still tell you, how far stud boards should be apart 16 inches and things like that. That's crystallized intelligence. He never lost that. Fluid intelligence is different, though. That's our ability to basically reason with abstract or new things. Did my grandpa struggle with new technology as he got older? Yes, he did. Okay. Do your grandparents struggle with, figuring out iPhones and figuring out their new computer and computer programs? Yes, they do, because that's fluid intelligence. That's adapting to new ideas, new concepts. So fluid intelligence decreases with age, crystallized does not. And you kind of see that with the graph here. Vocabulary knowledge, that does not decrease with age. It actually probably increases most of your life. But then as you look at some of these other things like, reasoning and speed of working out problems and things like that, they do decrease. So, finishing up with a couple of confusing terms there, but that's it for today. You guys have a quick little 5-question quiz about some of these topics for a Canvas quiz, and I'll talk to you next time.